Hello everyone, this is Troy from H3C, and today I will introduce you the principles and configuration steps of GRE over IPSEC. GRE and IPSEC are two protocols that we often use. Since the two protocols have their own advantages and disadvantages, we can combine GRE and IPSEC in use to build a GRE over IPSEC tunnel to make full use of their advantages. Let's briefly introduce the characteristics of the two protocols and the advantages of the combination of GRE over IPSEC. First, let's introduce the GRE protocol. It's a general routing encapsulation protocol, which is used to encapsulate the data messages of a certain protocol so that these encapsulated data messages can be transmitted in different networks. The path, which is the encapsulated data message, is transmitted in the network, is called GRE tunnel. It's a virtual point-to-point connection. The device at both ends of the tunnel can encapsulate and decapsulate the data packets. Through the GRE tunnel, the backbone network can be connected to different networks through the single WAN protocol, and the number of hops involved in the calculation between sides can also be reduced, thereby expanding the scope of network and connecting different sites of VPN across the WAN. After introducing GRE, let's take a look at the IPSEC protocol. IPSEC is a three-layer tunnel encryption protocol formulated by the IETF. It provides high-quality cryptographic-based security. It guarantees for data transmitted on the Internet. It's a way to achieve traditional three-layer VPN security technology. IPSEC provides two major security mechanisms: authentication and encryption. The authentication mechanism enables the data receiver of IP communication to confirm the true identity of the data sender and whether the data has been tampered during transmission. The encryption mechanism guarantees the confidentiality of the data by encrypting the data to prevent the data from being eavesdropped during transmission. Because of the protection provided by these two major security mechanisms, they can effectively prevent net attacks. So IPSEC is widely used in existing networks. After introducing these two protocols, let's study the encapsulation process of GRE over IPSEC. Okay, let's take an example of ESP and tunnel mode. GRE over IPSEC needs to encapsulate GRE first and then IPSEC. As shown in the figure, root 1's loopback access to the root 2's loopback address. First, the data packet needs to enter the GRE tunnel firstly, tag the GRE header, and encapsulate the source IP and the destination IP of the GRE tunnel at the out layer, and continue to look up the routing table through the encapsulated destination IP. After outbound interface is matched, the establishment of the IPSEC tunnel is established, IPSEC encapsulation is performed, and authentication protection is added to the data message. The advantages of using the two together are as follows. Point 1. Improve the safety of data transmission in the tunnel. Point 2. Solve the problem that IPSEC can only transmit unicast packets. Point 3. simplify IPSEC configuration. Okay, next, let's move to the configuration and the precautions of GRE over IPSEC. Okay, we have already introduced that the original method needs to be encapsulated with GRE and then with IPSEC. Therefore, we need to first import the original traffic into the GRE tunnel, which can be achieved by configuring a static routine to the distillation network. With the next hop pointing to the tunnel port, the data packet will be encapsulated in the GRE tunnel, and the encapsulated traffic will be the traffic that needs to be protected through IPSEC. There are two ways to configuring IPSEC policy. One is manual configuration, and the other one is IKE negotiation. In the manual mode, all the information required by SA must be configured manually, which is only applicable to the situation where the number of peer devices is small. And here we introduce the establishment of GRE policy through IKE negotiation. IKE first negotiates SA through its own authentication algorithm, encryption algorithm, authentication mask, DH level, and other parameters, and then passes the established parameters and generated keys to IPSEC, and IPSEC uses the SA to perform the process on IP packets, the specified method of encryption or authentication. Let's take the example. The two devices are interconnected through interface 0. The source and destination addresses of GRE tunnel are the addresses of the interface at both ends. The loopback 1 stimulates the terminal. Before configuring, remember to ensure that the routers between the devices at both ends of the tunnel are reachable. The GRE of IPSEC configuration process is manually divided into the following 8 steps. Step 1. Configuring GRE tunnel. Create a GRE tunnel on route 1 and route 2. Configure the source IP and the destination IP of the tunnel as the interface IP at both ends, and configure the tunnel port IP address. Here we configure the source address of the tunnel on route 1 is 10.0.0.1 and the destination address as 10.0.0.2. It should be noted that the tunnel source and the destination addresses of route 2 and route 1 are opposite. After the configuration is complete, you need to confirm that the GRE tunnel is successfully established and that the addresses of the tunnel ports at both ends can communicate normally. Step 2. Configuring an SCL. The IPSEC SCL must match the source and the destination addresses of the GRE tunnel port. In this environment, configure SCL on route 1 to match the traffic whose source is 10.0.0.1 and the destination is 10.0.0.2. The configuration on route 2 is the opposite of route 1. Step 3. Configuring IKE keychain. When IKE uses pre-shared key for identity authentication, both ends need to create and specify an IKE keychain. IKE keychain is used to configure the key information of both points in the negotiation. Create IKE keychain 1 here. include the pre-shared key and the scope of use of IK keychain. The pre-shared key configured by both ends in IKE negotiation must be same. Otherwise, identity authentication will fail. If you need to modify the shared key, it's recommended to undo the original configuration first, and then configuring the key instead of overwriting it directly. The scope of use of IK keychain. Use the command match local address to limit the scope of the use of keychain. That is, IK keychain can only be used under the specified address or the address corresponding to the specified interface. We use the default configuration here. That is the IP address of the interface, which applies the IPSEC policy. Step 4. Configuring IK profile. Configure match remote identity to create rulers that match the identity of the peer, used to verify the identities of the devices at both ends of the tunnel. When configuring pre-shared key authentication, the keychain used is the IK keychain 1 configured in the previous step. For IKE proposal, you can choose the encryption algorithm and IKESA survival time and other parameters. We use the default IKE proposal provided by the system here, without additional configuration. It can be adjusted according to needs in actual use. Step 5. Configuring IPSEC transform set. Select the security protocol, AH, ESP, and so on, and the default is ESP. Configuring the encryption algorithm used by the ESP protocol as 3DS CBC, and configure the authentication algorithm used by the ESP protocol to MD5. Note here that both ends need to ensure that the protocol and algorithm configuration used are consistent. Step 6. Configuring IPSEC policy. IPSEC policy supports manual configuration and IKE negotiation. Manual configuration is not commonly used, and here we take the IKE negotiation as an example. First, you need to specify the ACL referenced by the IPSEC policy. Refer to the related IPSEC security proposal transform set 1. Specify the IKE profile 1 and the peer IP address of the IPSEC tunnel. Step 7. Applying an IPSEC policy to an interface. It takes effect by applying an IPSEC policy on the interface if this command is not configured. The IPSEC policy will not take effect, so it's very important. The last step is configuring the routine. Configure a static routine to route 2 loopback on route 1, and the next hop points to tunnel 1. The reverse is true for route 2's configuration. And the above is the complete process of GRE of IPSEC configuration. The last part is about configuration points. There are 2 points that require special attention in GRE of IPSEC. Point 1. The rulers for the data flow ACL need to be configured as the tunnel's source and destination addresses. Point 2. The flow to the opposite end needs to be directed to the GRE tunnel. Okay, that's all for today's class. Thank you.